update VB equal to V old, okay, whatever this value, initialized value, this V old, plus we have given 0.01 as the learning rate. Delta naught, we just compute this. Let me run also. Let us see what is the delta naught. Can you tell me this delta naught is a scalar or a vector before I execute this? It is a scalar because only one node in the output, isn't it? Only one node in the output. If it is one hot encoded, your delta naught will get two values. Like the way what we discussed in the previous session in the PowerPoint presentations. I have kept two nodes in the output. We break down error total as EO1 plus EO2. Hope you remember that. Refer to that. So anyhow, here we have only one output node. So we got delta naught, which is a scalar value. So I substitute this 0.0419 into question mark. What is question mark? Similarly, very good. So the input to the bias input is 1, right? So into 1. You understood the formula, right? So the formula is new weight equal to old weight eta times delta naught times. In general, I write the formula. Okay, in general, let me represent this as x. So for bias, x is 1. Please make a note of it. So if I do V1, so V1 old plus 0.01, 0.0419, same error delta. Okay, time what? I should multiply this with 0.843. 0.843, got it. What is that 0.843? That is the hidden layer output from the first neuron, right? H1. In the PPT, I kept this as a H1, H2, H3. However, in the PPT, I have used only 2 hidden neurons, but here it is a 3 hidden neuron, H1, H2, H3. Okay, so this is the input to the bias. So I should use this as the input. For V2, I should use this as the input. For V3, I should use it. For all these guys, your error delta is common. You understood the calculation? So we are going to adjust using the error delta O, I'm going to update the weight matrix. Let us update the V matrix. So I hope all of you are getting the same value. If you are getting a different value, okay, share it with me. So we were supposed to do this calculation, isn't it? So to put everything in the coding, V is a column vector, 4 by 1, right? So V equivalent to what I did, V plus my original initialized V plus why plus sign in the equation, because both the minus we combine. Eta is the learning rate 0.01 into delta out, also a scalar, which is 0.0419 into currently we kept your hidden layer output is available in which variable? I kept in y in. Earlier we kept in y without concatenating the input to the bias. After concatenating, this is hidden neuron output 1, hidden neuron output 2, hidden third neuron output 3. And then after concatenating 1, we use this variable y in. So currently my data is available in this form. Okay, hidden neuron, first neuron output, second neuron output, third neuron output, and this. But this is a row vector. Please understand, this is a row vector, 1 by 4. A column vector 4 cross 1 cannot be added with a row vector because it is the element wise, it's a vector operation, element wise operation. So here I cannot feed it like 1, 2, 3, 4 values. I cannot feed like this. So matrix compatibility, vector operation compatibility issue will come. So what I need to do, I need to convert this into a column vector like this. Okay, in Python, you know it very well that dot reshape -1, 1, if you do, your row vector will convert to a column vector. So here I'm reshaping my y in to a 4 by 1 column vector. So the resultant value you will get, what will happen? This is a scalar. This will be multiplied with this. This will be these two guys will get multiplied, and in turn it will get multiplied with this. So 1, 2, 3. These three product, and finally these three product will add with this first element, right? Then the second element is going to add with once again this one, the second product. These three product add with the second element. Third element, these three product. Fourth element. This is how the calculation goes on. So finally, this plus this, your V gets updated. Let us see the updated V. Just I wanted to show you any vector, if you just apply reshape, how it turns into a column vector. Initially, we kept our x as a row vector, right? X is, what is x? 0, 1, 1 is the x. If you, for x, if you apply reshape, your row vector turns into a column vector. 1 by 3 becomes 3 by 1. So we got updated. This is the updated V matrix. Out of curiosity to know what was the earlier 0.1880. Okay, the third and fourth decimal places changes. Okay, if you want faster change, it is a very slow changes in the weight, right? If you need a faster change, probably I need to increase the learning rate. Instead of 0.01, maybe you can keep it at 0.05 or even 0.1. Okay, quickly it will adjust the second decimal place or even the first decimal place also. So that is what the control of the learning rate. The higher the learning rate, very fastly it is going to update the weight. But however, initially I wanted to start a slow change. How a slow change is going to impact the overall error. So look at the second weight, 0.0807. 0.0807 turns to 0.0810. Then V3, 0.738. Only in the fourth decimal place, I guess. Change. 7384 change to 7387. 4417. 4413 change to 4417. In case if this delta, if you have slightly higher value, you could see a larger variation in the weight. So we have updated the V matrix. What is the next step? Next step is to update the W matrix. To update the W matrix, okay, we need to understand the architecture.